Burnouts are far too common on a VRF system. They're typically the result of poor piping installation, and that initial failure just plants a seed of really poor performance for the rest of that system's life. This is where flushing a system becomes really critical. And I'm going to walk through my process on how I like to do this. There's one of the key factors that you've got to think about if you choose to go the flush route. You're going to have a longer evacuation. RX11, last time I looked, it boils at like 70 degrees. You can actually hold it in your hand and watch it flash off. Now, don't literally do that, especially without a glove on, but the point is, I have done it, so I can contest that it does work, right? It's really easy for it to get collected, and even in small quantities, and it's gonna take longer to boil that back out. One of the non-negotiable steps, you have to put in suction dryers, and specifically use a shell dryer. Now, if you're not familiar with that term, a shell dryer is the big fancy ones you think of maybe with refrigeration systems, where there's a core that goes inside of a steel shell, and you take the end cap off of it, and then that core can slide in and out. That's what you're going to want to use in this type of application. I don't recommend trying to just do a regular suction sweat dryer. Neither does the manufacturer. Something else that's critical, you're going to want to install a series of ball valves. Now, you're really going to want at least 3. 2 ball valves are going to be for the shell itself to isolate on either side, and 1 ball valve is going to be for a bypass that's going to sit in the main suction gas line. The purpose of this is so that when you are ready to remove the suction dryer from operation, you can just isolate it at its 2 ball valves and open the main bypass valve, and it's just going to flow like normal, and the system can live its normal life. These dryers are not meant to stay in the system for a long period of time, and you've really got to minimize how you do this. And I have to manage using suction dryers on VRF systems differently from how I manage using it on a regular system. On a regular cooling circuit on RTU or something, I may leave that dryer in there for 3, 4, 5, 6 months, depending on what it needs, in order to really clean that system up and just do my tidying up that I didn't get with the flush. This system has got to be minimized, and I'll talk a little bit more about it in a few minutes. On the ball valves you choose, make sure you get the ones with the pressure taps, and there are actual refrigerant rated ball valves that you can buy at the service shop or off the shelf. United Refrigeration as a national brand, they're able to get those relatively easy. They just need to know what pipe size you need. And the shell of the dryer itself, and this probably actually wouldn't be a bad video to do on its own, but the shell is rated in size of like 48. So a regular 48 core is a single cored shell. A 96 core is a double core. It's got 2 48s in it. So for most of the applications we use in the tonnages, what decides that is the tonnage, and Sporlan has a whole chart in a book that gives you what sizes you need based off of the type of refrigerant, and it gives you what inlet and outlet pipe size is going to be required to move that tonnage. Most of the time when I've gone in to do this, I've been able to match the shell in and out to whatever my suction lines line size was, and looking at it from a tonnage perspective on how to properly, it all lines up. Now, the key factor, make sure the dryer is fully horizontal. You want it completely level with the pipe. It doesn't need, especially don't let it have a downward tilt, but you also don't want it to have an upward tilt. It needs to be completely level. That way you can manage oil. It all comes back to oil. So that's the critical thing. I'm not going to harp on it, but we've got to pay attention to how we're managing our oil in a system like this. Just a rough rundown of what I'm talking about. You want the system in evacuation mode, so everything is opened up fully. You're not going to get much flush through the outdoor unit. And honestly, I don't suggest even trying. The piping network inside of those outdoors is so intricate, there's so much in there, you're very likely going to just cause more damage trying to flush through that outdoor unit than actually just leaving it be. I guess my point is the return on that investment is low. So we're going to stay focused on the actual line set in the indoor units, because that is worth it to me. So what I like to do is I will separate the line set from the outdoor units, and typically these units are mounted up at a higher elevation, If they're not, it's okay. You're just going to flip this next part around. So assuming that my outdoor units are, say, on the roof and I'm going down with my piping, then I'm going to separate that there, and then I'm going to go down to the next lowest point, which is whatever floor it stops at for the main line set to take off to the headers or branch boxes, whatever. And I'm going to stop it there at the very first branch box, say, that I come to. And that's where I'm going to separate the pipe. So that's probably going to be the longest single stretch of pipe you're going to have throughout this whole job. From there, I'm going to push my flush from the top side down. Let gravity be my friend here. Now, if I was the other way, I'm just going to invert that, right? So if I'm on the ground, I'm going up in the air a couple of stories or something, and I'm just going to go to that first section, chop it, and then flush back down towards the outdoor units. Not a big deal. Make sure you got somebody down there with a bucket ready to catch. That's the critical key. When I am flushing through there, what I am expecting to see is the flush to come back clear and fairly clean looking. Because of how stretched out things get in a VRF, it's not uncommon that it doesn't take a whole lot of flush per section of pipe, because typically the contaminants get spread out so far through the system. Whereas with a standard cooling circuit, you may have sections of pipe where there's a substantial amount of acid and corrosion and sediment built up. I typically don't see that as much with VRFs. Anyway, so you're going to push through each of the pipes, whether you have a 2-pipe system or a 3-pipe. Either way, you're going to do this for each section of pipe, both your gas and liquid lines. Once you've done the main section of line set, then you're going to break out each of the rest of it into its own individual parts. So between branch boxes, and then separating each of the indoor units from the branch boxes, and then pushing through all of those. And typically when I bid a job like this, you're talking, 2 weeks worth of work. It's really intense what you're getting into, but it's like I said earlier on, how far do you want to go? If this is just unnecessary for your specific situation, don't go this far. I've worked on a lot of situations where they're 3, 4, 5 compressors deep in their burnouts because they haven't fixed their oil issues, and then the first and second burnout, they didn't do a good job cleaning it up. Sometimes they never even put the dryers in at all. They didn't even realize the system was acidic because they never tested it. All they did was just slap a new compressor in there and turn it on. If you're that deep in the hole, you're basically going to have to do this far of an in-depth in order to get this system back to any kind of sustainability. Anyway, I could go on a tangent with this and just how bad this is, but thank you for listening. I like to add my Scavenger during the evacuation process. On the outdoor unit, if say I've got multiple that I had to do the compressors on, I will take a hose from the suction gas line, put it into the bottle, let it draw into the system while I've got the evacuation pump running somewhere else. When the system gets running, I want all that Scavenger to pull straight into the compressors that I want it to get into to help treat that side of the system. On the dryers, you really should be coming back every day or two right at first and really keep a close eye on it. You're paying attention to your pressure drop across it. Make sure you've got taps available where you can see that pressure drop. And it's very likely, especially with a dirty system, you may be changing that dryer out every couple of days. If memory serves, I think LG specifically states 48 hours or something along those lines, like not to leave it in there longer than that. In my experience, it's not as rigid as that. So usually once you get past the first 1 or 2 changes of the dryer, the system will really start to smooth out and it'll start to clean up a lot more. I don't go more than 2 weeks at a time running that dryer on the VRF system. And once I'm done, I will go in, isolate, I'll go ahead and pull that dryer out so that it's not in there and somebody can't accidentally try to run through it again in the future. But I'm going to bypass the shell entirely. But I know that I'm ready for the dryer to come out long term is when I can go 2 weeks and I don't start to have an actual drop across my dryer. I very much expect it for the first couple of weeks. There's not a good way of testing these systems once it's all back together. We don't have oil access ports. doing the quick test, litmus things, the I think that's what they're called, quick check or something, they're junk. Okay, don't rely on those tests to tell you really anything at all. I don't even put them in my truck. I don't like my technicians I've worked with using those. There's a lot of situations where we tested it with that. It perfectly passed the test. The paper didn't turn any kind of colors, did perfectly normal. Then we opened the system up and did an oil test, and like with a phase 3 kit, I highly recommend those. That's when we discovered that it actually had fairly high acidity. Now, expect a longer evacuation time. If you're used to pulling evacuations on these systems in a day or so, you're not going to. This evacuation is probably going to take several days at best. And I've done a video on how I go through an evacuation process, and I talk a little bit about if I'm coming in after a burnout or something. So I'd recommend go check that out and go see what are all the steps and processes, what are my preferences on how I'm going to go through that evacuation. I've also gotten a pressure testing video, so whenever you get ready for that stage of it, because those are all a part of this, leak repair or compressor failure, just major repair part of the system, or just maybe you're just simply commissioning it, watching this video because you're curious. Go check out that pressure testing video. I also talk about in that same video kind of my leak search process, in addition to how I'm pressure test, because I think both of those are very heavily intertwined. Hopefully that'll give some value and benefit to you. I've got tech sheets produced for these VRFs, and I've got more coming, more on the way. Those tech sheets are a quick reference guide. So essentially what I'm trying to do is I want to help you take less time and just have the data that you may not have had to get a more accurate assessment and a diagnosis. Many times, because the manuals themselves can be very complicated and long-winded, it can be hard to make the right call, to know what's supposed to be what, because we just don't have that immediate data at our hands, or we've got to spend the next 30 minutes trying to figure it out. These quick reference sheets are built to be a guide to just get in there, okay, this is my info, this is my data, get it, go, and push you through that repair or that troubleshoot far faster. So if there's any of those on my website that you would find beneficial, or just maybe go grab some of the free manuals I have, please go check it out at hvactime.shop. With that, MTT, take care of your family, take care of your spouse, take care of yourself. I'll see you around.